All right. Hi, everybody, and welcome to the January edition of the new year for Multicloud Happenings. And we're really happy that you joined us today because we're going to talk about a relatively new feature around security. And so, hi, my name is Tammy Bednar, and I'm a product manager, and I focus on the Exadata Database Service, Database Service, and Multicloud. And with me today, I'm so excited, is Jeff Wright. Hey, Jeff. Okay, you're going to hear a lot more from Jeff in just a minute anyway. So, just kick us off, got to cover this safe harbor statement that, what Jeff and I say is intended to outline our general product definition, but you cannot write anything that we say into a contract because we're just product managers and, that's how that works. But anyway, that's what that's about. Okay, so let me just level set very quickly that this is the Ask Tom session on multi-cloud. So maybe the first question is, why do I want to use more than one cloud? And maybe this is like a no-brainer, but why do you want to use more than one cloud to run your business? Well, you want to optimize your costs, the functionality, performance, because you get to select the best data source and the best application source to run your business. That gives you the flexibility and the opportunity to be able to choose that. Not always the case in the past, but hopefully you have more and more control over what you want to use to run your business. And then you also want to look at managing and governing the data. So maybe for some reason that you need data in a certain region, in a certain country. This also gives you the flexibility with multiple clouds and where all the different resources are located to choose the cloud that you need. And then finally, meeting regulatory and data residency needs, kind of the same as manage and govern, that you can choose where you need the data to be to meet that regulatory that security, I should say, compliance based on the business as well. Well, Oracle is in other clouds, as hopefully you've joined us over the last couple of years with multi-cloud happenings, that can run in other clouds, but now even more, we now have a solution in which you can select the same platform, which right now is called Exadata, and be able to run your workloads wherever you need them. Whether Exadata is on premises, it's in OCI, whether it's a Microsoft or Google Cloud or AWS, you can get the same experience no matter where you want to run your workload. So this is really exciting times where the capabilities are. So we've been talking about this Oracle database solution, and that's where we are co-locating our services in the same region as our partners as well. So not only do you have the Exadata platform, but you also have other services such as Golden Gate, our autonomous recovery service for backup recovery, and much, much more. With these solutions, it's giving you the ability to have the highest availability for your data, fully automate a lot of the processes and the tasks that you have to perform with being within the database, giving you the fastest performance. And hopefully you've heard about the new generation of our Exadata platform, X11M. If you haven't, I'm happy to give you a link of where you can find more information on that. And then a greatest agility, because truly, again, being able to run your workload wherever you need it. So I was talking about the Oracle Database Solutions, where we partner with Microsoft, Google Cloud, and AWS. Very high level, what that means is that we are co-locating our Exadata platform and our services in the same data center with our partner applications and partner services, while still having our control plane within OCI region to manage all the cloud automation as well. So lots of exciting times. And Jeff and I have been very fortunate to be on lots of conversations with our customers about these solutions. So I'm really excited where we're at today and where we're going. Now, I'm really excited today to have Jeff join us today because he's going to talk about security. And if you don't know, Jeff is a guru of Exadata security and a lot of other stuff. But Jeff knows everything you want to know about security, and he has been working on this new feature release called Delegate Access Control. I'll get it straight in a minute. So I'm really excited to introduce Jeff and hand it over to find out what this feature is. All right, Jeff.
Hey, thank you, Tammy. And I'm happy to be here. I'm glad you're all taking a little bit of time to listen to me. And that service that I'm going to describe is an extension of what we've learned with operator access control. And while I'm certainly excited for you, Tammy, to share all the things that I've learned, it's because I stand on the shoulders of giants. And there are a lot of banks, a lot of telcos, defense contractors, and people that have helped with this. And this is a result of, Oracle building something that people are demanding. So, we look at this service, and I'm going to describe it. And I know this is multi-cloud happenings, but one of the things that's interesting about how Oracle delivers this is it's applicable to all of the virtual machine implementations that we have for all of the Exadata based data services. So Exadata Database Service dedicated in OCI, it works in Exadata Database Service in Azure and Google and GCP. It works with Cloud@Customer. So this is an example of us building this authentication control and isolation control so that it goes end to end inside of the database service. So as we talk through this, I'll describe kind of a unique piece about why you want to use this and why you want to use it with a multi-cloud, but then we'll go into the mechanics knowing that we can generalize it to all of our solutions. A little bit of background in terms of the story for folks on the call or listening to this that aren't in the day-to-day business of security. We'll talk about what the data show, the kind of problems that we need to solve and how the Oracle system maps to those problems. We'll provide you an overview of how the software works and some details about how the software works. And then a quick implementation. We really did integrate it end to end in the cloud. And the nice part there is, we'll show it as point and click, but it really is point and click to set up. Point 6, supplemental block diagrams. If we need to talk in the future, I'm happy to meet with you or your customers. Simply put a meeting invite on my calendar, send me a direct Slack message or something like that, and we can go into detailed mechanics in the future should we need to. All right, so the first one is when and why you should use this. So this is something is if a customer needs to, first and foremost, allow Oracle support staff to access their virtual machine. So if a customer says Oracle never needs to log into my VM, they of course don't need to use this service. Now, Oracle is a partner, right? When we talk about bringing the Oracle database to our partner clouds, one of the things that we're doing is we're bringing Oracle software. Delegate Access Control allows them to bring Oracle people. And the Oracle people will be delivered. The first one is you need Oracle support staff to access your VM. And an important part is there are cases where a customer developer might need some help. You're a developer, you're not expert in Oracle, you want to know how something works, something's not right. You can open an SR from your OCI interfaces. And then from that SR, you can say, Oracle, help me out. And if you've configured Delegate Access Control, the Oracle support person can click a button on an Oracle interface to ask for access. And then the software will orchestrate this temporary credential in a Chroot jail with an integrated audit system to allow for a mechanism that not just allows the Oracle support staff, but does it within strict compliance requirements for access control and audit. It also minimizes the time people will have access. So we use a time-bound credential. That credential is automatically removed, so we don't have this security risk of credentials that are left lying around. It minimizes the number of people that have access. So when you say, hey, Oracle support can access, you're not providing access to the whole support organization. You're providing access to the person with the ticket that has asked for access to the system. If Oracle were to add another person to the ticket, because sometimes we need more than one, you receive a notification and you can be made aware that now there's 2 people that can access. The next one is when you need to enforce minimum privileged access. So that we love to log in as root because that's fast and easy. We can fix everything, but it's crazy dangerous if you're in the business of security. So when people talk about enforcing minimum privilege access when they're managed, that's what this software does. And then finally, it's not enough to have preventive controls in the system. We need a detective control and an audit control that proves that the system has been managed to compliance and risk standards. So integrated in Delegate Access Control is a detective measure and audit record system that provides machine readable and human readable audit records that are very convenient and straightforward to use. And then the next one is you're also using this because you want to simplify configuration, operation, and audit. So Delegate Access Control provides a standardized method that's implemented across any of these database cloud systems. And the nice part about the Oracle engineered system approach, so just like Exadata maintains the context of the I/O from end to end, and we can do all kinds of amazing things with how we optimize I/O processing, we're extending that to how we configure, operate, and audit access controls to the system. This has the effect of reducing deployment time and improving operational efficiency. We go through the interfaces, we'll show that this literally changes the configuration of the system measured in minutes to tens of minutes. And then access to the system is done on the scale of minutes to tens of minutes. And it's done with a minimal amount of training and coordination and software. So it really improves operational efficiency. And it now allows you, because you can gain the value of Oracle as a service provider. Just like the customer is using the Oracle database at Azure or the Oracle database at Google or AWS, you're using the Oracle database software because it's the best software to do the job. And you might ask the question of who's the best support staff when you want to work with that software. We as Oracle will argue that our Oracle people are the best support staff. So this now gives you a mechanism of getting Oracle people to help with the Oracle software and doing it in a way that we've standardized so that, we're really aligned with how banks run their businesses. And then finally, we talk about the unique financial, operational, and security benefits of this integrated cloud service. So what do we have for multi-cloud is a customer that has chosen to deploy in somebody's cloud for reasons that are optimized for that cloud. They might be in Google, Amazon, and Azure all at the same time. They now have decided that the Oracle database is the right database in all of those. So we might say that the Oracle database becomes the target for the multi-protocol JSONs and vector databases and all that kind of stuff. And we like the financial, operational, and security benefits of the Oracle database with this integrated cloud service. So the next part is we're in all these different clouds. How do we mechanically control that Oracle staff access to bring the unique value of Oracle people? And the way that we do that is Delegate Access Control. So if we really stand back and think about it, we're integrating the access controls end to end so we can integrate the people end to end with the software and become what we'll argue is the best data processing partner that a customer can have in any cloud. All right, so why do we have this anyways? The world's not a perfect place. Like people do crazy things and, we're not always all aligned. And, people exist that, don't agree that the laws that we've put in place and the rules we put in place make sense. So if we go to the 2024 Verizon breach report, one of the industry standards for what really goes wrong, the links in the slide that you'll have access to will give you access to the report and the summary. A few important things come out of this. First, people are involved in 68% of the breaches. It's still people. And it's okay. We want to know who we are and what we do. And we're building this to manage the lion's share of the problems, which is people. Delegate Access Control enforces separation of duties, which helps to prevent a single person from acting without approval by a second or third person, and provides an audit to further separated staff. People ask me what I do for a living, and one of my jobs is to remove clandestine access from computer systems. We want to make it so when people work on these systems, they do it in the bright light of day. They do it in coordination with one or more other people. And we do it in a way that we can all be comfortable that we're doing the right job. And we get rid of this whole problem. We want to prevent people from sneaking around without approval. How do people sneak around without approval? At 31% of the breaches, they've stolen someone else's credentials. So if you have an account on a system with a credential whose password is known by more than one person, then it's no longer a secret. Arguably, when someone knows a password, you ask them like, "How do you keep your secret?" And I don't know, maybe they keep it a secret, but that if you've shared your password or written it down somewhere or somehow typed it into something, I mean, we've all typed our password, right? What if there's malware behind that stole my password? 31% of these breaches over the last 10 years involve stolen credentials. Delegate Access Control implements user-specific credentials that are temporary and authenticated via FIPS 140-2 Level 3 hardware multi-factor authentication. For those of you that work with Oracle stuff, we use a YubiKey. It's a publicly available device. You can buy it from Yubico. The FIPS 140-2 Level 3 standard means the private SSH key is secured inside of the hardware device such that the hardware device prevents access by other people. So I don't know my private key. I only know the public key. And by having that device, the authentication happens when you have the physical device and you have the passcode device. So it makes stealing credentials much more difficult and stealing credential at scale very difficult. We all hear about ransomware. I mean, think about, you ransom something, like somebody runs an encryption program and encrypts your data, and then you're stuck. And you're like, wow, what if you encrypted the TDE wallet? I mean, you don't even have to encrypt the database. You just have to ransom the wallet. And now you can't open the database. Like, ransomware is a big deal, right? The thing that Delegate Access Control does is by enforcing privilege limits, it removes the scope of where ransomware can reach. So if I log into a system as root and I have, malintent, I can install arbitrary software. I could encrypt an arbitrary file. It's, my capacity of root is to do anything on the computer. For Delegate Access Control, I don't always work as root. So although sometimes we have to be root, the important part with Delegate Access Control is we can do work without being root. And, kind of by example, when you go into a doctor's office and they run a procedure, maybe they need to take a small biopsy or something, they use a little bit of a local anesthetic so that they can take out the small biopsy and send it to the lab. They don't need to put you under general anesthesia. Of course, general anesthetic, they could do the same thing, but it's dangerous and risky, and you don't really want to do that when you don't have to. This is kind of a mechanism, right? If root access is like general anesthesia, we could do anything. We know it's a little risky, but we have to have that capacity because we're cutting you wide open. If we just need to do a tiny little bit of work, we can come in with far less privileges. 28% of breaches have errors. Somebody made a mistake. What's the way that we use to help prevent humans from making a mistake? Well, we make it so you need more than one person. So with a second person in the chain, the way that Delegate Access Control works is you have to start with a ticket. Software checks for a ticket. The next thing, the ticket says, I've got to do some work on a system. There's a target for the system. There's the work I need to do. I think I need to work on that. So I open an access request. I say, I need to work on this system to do this work. Someone else somewhere has to read that request and approve it, or they at least have to approve it. And we're going to assume that they read it, or at least hope that they read it. So what we're doing is we're helping to reduce these mistakes by associating the change request or the ticket with the request for the access in the system it's supposed to be for, passing that to an operator who's supposed to do the work, and then a separate approver who has to look in and allow the work to be done.
Hey, Jeff.
15, yeah.
Oh, okay. Sorry, you're on slide 4. I thought you were on a different slide. Okay, never mind.
Yeah.
All
and
right.
then, finally closing this off, 15% of the breaches involve a third party, but you need a third party. Like, a third party is a value, right? So it's true that independent companies, third parties, will break into your data center or customer data centers and steal stuff and break stuff and cause problems. But you want to use a third party because we as Oracle can deliver you unique value with Oracle people, just like we do with Oracle software. So Delegate Access Control allows you to control when Oracle can access your systems, enforcing privilege limits during access and providing audit records so you know what we did. So for these major things from the Verizon breach report, we as Oracle have built software that addresses these main points. The next one is you've got a customer security organization. Everybody has them. They've taken great care to make sure that the security controls that are enforced in their cloud are aligned with industry best practices. These are straightforward to look up anywhere that you find anybody with privilege access management software. We'll save a little bit of time going through how this slide works, but what we want to let you know is that you're not going to surprise a security person with the implementation because it's designed to implement industry best practices. So people will say you need unique temporary user-specific credentials to isolate sessions. We never share an account. The software does that and enforces it. People tell you we need to have an access record to all the things you did. We use the standard Oracle Linux Audit D open source software to provide command and keystroke monitoring. Our industry has used this for decades. Everybody knows how it works. They need to have access to those logs. We will stream those logs to their syslog server. We can stream them to the OCI logging service for recording. Everyone tells you you need multi-factor authentication. We agree, it's a best practice, and we do it. PIPS 140-2, level 3 compliant. This is the gold standard. People will tell you you shouldn't have any access to the system, zero standing privilege, just-in-time access. Only after there's a ticket should there be a software that allows access. That's exactly what this does. We remove remotely accessible credentials, so Oracle doesn't have a remotely accessible credential. When we need one, we generate a temporary, unique credential in response to IAM authentication. The software automatically revokes it at the end of the access so that we make sure that there's not a standing privilege for Oracle unless the customer has approved. And then finally, we're not adding users to directory services. We do use an agent in a VPN because we as Oracle have chosen to control our staff with VPNs. However, the important part here is that there is not third-party software that's built into the system. The software that we're using is integrated, tested, and validated by Oracle. It's not a third-party agent. It's included Oracle software. There's no additional VPN that's required outside of what Oracle requires from its employees. That's integrated into the system. To get to these endpoints, you have to have this access. We don't use passwords because passwords are terrible. We use these hardware multi-factor devices. The part about the directory service is that you don't want to be in a business of onboarding a third-party provider to your identity system because of what's described as the joiner, mover, leaver problem. And when you're thinking about multi-cloud, a customer in their data center has federated their identity provider out to Amazon, Google, AWS, and they have all of their staff that they are managing, and they've got the central federated identity provider so that if they were to terminate or promote or change their employees' HR system, they can automatically change their access in all the clouds. Oracle, if you were to try to onboard a separate person, there's a gap. As if the Oracle person, if I got promoted and I'm no longer, supposed to be working on these systems, or if I change jobs and I'm no longer supposed to be working on these systems, if I had a customer credential, the customer might not know about my job code change. If the customer doesn't know about my job code change, they might leave me with access to a system that I no longer have a business requirement to access. If you use Delegate Access Control, the Oracle HR system controls who's allowed to access. Well, the Oracle HR system is integrated with Delegate Access Control, so we know who's allowed to access the system, and it removes the gap of a person's credentials being valid on a customer system when they're no longer supposed to be there. So what we've done is we've made it so that we can solve the directory service joiner, mover, leaver problem with these just-in-time credentials and zero standing privileges. And we can do it because we've integrated these components together that include the Oracle HR system, the backend systems that we use to assign people to do work. And then the orchestration of these temporary credentials is how we tie the affinity of the IAM user to the SSH session. So kind of high level overview, when we're in multi-cloud and they're saying Oracle support and they start scratching their head and they're like, oh my gosh, how are we going to deal with bringing Oracle into OCI and Amazon and Google and making this happen? This is integrated software. And we remind them, you as customer control, when we access the system, you control the time the time you'll know, the number of staff you'll know, the privileges we have, you know these. When you agree to yes for those three numbers, the system starts working. Software enforces minimum privileges, and that's what we want so that we as Oracle can run remote APIs or predefined shell commands. We don't even need to log in, right? We can make it so we can do something on the system for diagnostics without the risk of access, and we can do it in a way that's controlled so that's at the customer's control, customer's pleasure for the diagnostics. We do non-root interactive shells so that a Linux root jail is the technology that enforces privilege limits. And if we need root, it's only available when it's necessary. We have to ask for it only after the customer approves it. And it's via sudo or su as a named user. So we can still establish in the audit trail, I landed as a temporary user that's associated with only me, JT Wright. And then if I ask you to root, you can tell what I did as root compared to what one of my colleagues has done. Commands and keystrokes are traceable to specific Oracle staff, again, via the FIPS 140-2 Level 3 hardware MFA standard. The Oracle Linux Audit Service records, they're hard to look at as a person sometimes, but everybody knows how to process them. And finally, because it's Oracle Linux Audit Service, we can forward to the SIEM systems of the customer's choice. Some benefits, right? OCI automation does the orchestration. And this is a really good benefit, right? Customers might start off saying, oh, I hate OCI. I've not approved OCI. Like, I don't want to go to OCI. And I was like, the only thing you need to do is send the API. The value of that API is this orchestration tool eliminates direct access to service accounts. It eliminates shared authentication secrets. It eliminates static network access to a VM. It has a direct tunneled SSH endpoint to a target to prevent a man in the middle of attack. That OCI orchestration has a lot of value, and that's important. And it prevents personal information from being exposed to help prevent collusion between the requester and the approver. You get root jails, which are unique from Oracle. So these are designed, tested, and engineered by Oracle to enforce privilege limits. Again, we as Oracle can write them because we've integrated the Exadata. We know it's sensitive. We know it needs to be accessed when work must be done, both of which are important. And because of that, we have engineer reviewed, tested, designed root jails that protect sensitive information and reduce risk while permitting value-added work. And an important thing when someone says, I want to have an allow list for the commands that you can do that are safe, an important argument to make is first, all the commands on the system are there because sometimes we need them. Then the second one is I have cat, simple tool like cat. And if I can run that on any device, I can look at any piece of information. I can copy files. I can bring in data. And if I can run cat, I can steal data. I can look at anything with cat, and I have to have it. And so cat itself is a powerful tool if you're root. But if you're not root, you can't run it on everything. And that's the important part, is it's not the command so much that's dangerous. It's what you can run the command on. The root jail makes it so the reach of the user is constrained. So commands that they need to do real work that could be used to do malicious work, we help prevent malicious work by reducing the scope of what you can run that command on. Like Tammy said in another talk, that I was watching her with Exadata, the fastest IO is the one you don't have to do. And just like we remove the need for IOs because of the Exadata software, we also can remove interactive shell access. If the safest computer is turned off and locked in a vault, it's not very useful. The next safest computer is one that's turned on and running authorized software with no people accessing it. Rather than have a person get a shell, we just allow them to run a list of diagnostics commands or an API via interpreter. That makes it so we can do work without shelling in. That's almost as good as not being able to shell in. And again, we're reducing root. So these security benefits are really important from a risk management system. And we hope that we can help a customer onboard and embrace these OCI APIs, because if they run these OCI APIs, they get something here that's very difficult to do absent these OCI APIs. So let's talk a little bit about how this works. So I know we usually think about these technical talks, but if we think about access control in 3 layers, the first one is entitlement management. So what we ask from a security perspective is, do you have an entitlement to access a system? So which systems can be accessed as an entitlement? Who is allowed to access a system? It's an entitlement. What privileges can I ask for? That's an entitlement. All of the entitlement management we run through OCI interfaces, and we control with OCI IAM. The benefit of controlling it with OCI interfaces and IAM is that each entitlement is audited through the OCI audit service. So the software helps us to know who asked, who approved, what did they ask for, what system was allowed to be asked for, and enforces that. So unless the policy has been applied, obviously you can't, well, the OCI IAM will control that you can't ask for access to a system. Once it's been allowed to have access, you know the audit record of who approved that this can be used with delegate access control, who asked. So the entitlement is the business part about what's allowed. The second layer is enforcement. So once we describe what's allowed, we use software to enforce so that what is allowed, and we prevent things that are not allowed from happening via software. The technology for enforcement is standard open source Oracle Linux stuff. So the Oracle Linux chroot jail is engineered into the system. The chroot jail is an open source software. People can see as they like, they can understand it. Oracle has built these chroot jails to enforce the privilege limit. Temporary network access is done via just-in-time Bastion servers and virtual cloud networks. These technologies customers can use in OCI today. It's a very straightforward public technology. We as Oracle make great technology, and we use it because it's great technology. The third one is SSH. Who is allowed to access, whose entitlement is allowed to access that system? Again, back to FIPS 140-2 level 3 hardware MFA. It's hard to beat this. So once we've enforced the system, we do have to allow access to systems in excess of the work that needs to be done, because there's wide ranges of work that have to be done, and we have to be able to simplify the controls so that there's a handful of different ways that we can access. We know that, I'm cleaning your house. You might hire me as the house cleaner, and I say, okay, great, I'm going to clean your bathrooms and I'll clean your kitchen, but I'm not cleaning your bedrooms. You might say, Jeff, just clean the downstairs, don't go upstairs. I'm like, that's great. The audit system here is like the cameras that you have in your house that watch all the work that I do. I have my own little helmet camera or my chest camera where I'm cleaning your house, and I show all the things that I'm cleaning. And I've shown that I clean your bathrooms, I clean your kitchens, vacuum your floors, and then I've left the house, and you can see everything that I've done. And I wasn't supposed to go upstairs, so I didn't go upstairs. And I proved to you I didn't go upstairs because of that audit system. We do the audit through the standard improving Oracle Linux security features, and we integrate them with these OCI services. So it's the Oracle Linux Audit D that provides command and keystroke logging for Oracle operator access. We can optionally integrate this and send it to customer syslog servers, customer SIEM systems. Because it's Audit D, it's very straightforward to stream it to a syslog interface or a SIEM system. Customer can add their own agents to that are compatible with Oracle Linux to the VM so that they can send this to their SIEM system. Again, everybody knows what these Oracle Linux Audit D records are: TTY records, proc title, that sort of thing. We'll skip through this one really quickly, but when we talk about the process flow, Delegate Access Control brings the concept of service provider to OCI. So a service provider is an entity that would like to do work for you. That service provider has a group of people that are allowed to deliver a service. So our service provider puts a service in a catalog. We'll show an example shortly. And you as the customer can look at the service catalog and subscribe to a service. Cloud operations assisted patching, cloud operations troubleshooting, Oracle support assisted patching or troubleshooting. Once you've subscribed to a service, you can create a delegation control that allows a virtual machine to be serviced by the provider. In that model, the provider can use their credentials to ask for access to the virtual machine, which is subscribed to the service, and then the customer can approve that access. So logically, what this does is it gives the customer a provider, like, a maid service, Molly Maids, I work for you, Molly Maids, and I'm going to come clean your house. It could be like a hospital, you go to the orthopedic surgeon and you need to have knee surgery or something like that. Each of these service providers has a thing that they do. You allow their access to do the thing they ask, you approve, and it helps you not grant blanket access to Oracle as a corporation, but just allow different providers to access at different times. And this is a new model of how we're dealing with people in clouds, because it separates the identity management of the providers, which is something that providers do specific to themselves, from the customer's identity system. And an important value proposition here is the service provider is the one who knows what their staff should be doing. If you're an orthopedic surgeon, you want to make sure you got board certified, or your orthopedic provider, you have board certified surgeons, doctors, nurses, you meet all hospital regulations. If you're Marriott Hotels, you have the 27-point checklist and you train your people to clean the hotel rooms. We want the service providers to make sure their staff are doing it right. And we want the customer to know you subscribe to an accredited service provider that's doing the work right, as opposed to a customer needing to figure out how to tell an Oracle person how to take care of their virtual machine, which is way harder for a customer because they don't know much about the virtual machine compared to Oracle. We have a couple different service providers today. Oracle Database Cloud Customer Support. This is the Oracle Database Support team. So now when you click Open SR as a customer in the Oracle Support portal, the Oracle Database Support team can see that your system is under Delegate Access Control. They make a click to access. It invokes this workflow cross-tenancy in the cloud. This is all included in the CPU subscription, no additional cost. Oracle Database Cloud Operations. This is the Cloud Ops team they already use for their infrastructure today. This is an included cost, included with the subscription with no additional cost. Oracle Engineered System Deployment and Infrastructure Support. This is our CSS, or Customer Success Organization. These are the folks that have delivered things like Platinum to you. And we have a strategic customer program, which are our white glove services, special Oracle staff that help exceptional customers with exceptional use cases. Both engineered system deployment and infrastructure support, strategic customer programs, those are negotiated separately from the OCPU subscriptions. Delegate Access Control provides 6 levels of privileges. And this is a unique Oracle technology that we as Oracle can do because it's an Exadata database service. And we as Oracle know end-to-end how to work on the system and how the system works. The lightest thing you can do is API access. This, if an Oracle support person wants to help out with patching and wants to run the OCI API to do a patch pre-check, this allows them to run that API specifically so that they can do a patch pre-check using an OCI API without the need to onboard them into the customer tenancy and write IAM policies and all that other kind of stuff. And it's isolated to the specific API. Next up on the system is log access. So today, a customer can have opt-in for Oracle to access their logs. There's an Oracle log monitoring service that we provide, but that does provide 24/7, 365 access to the logs. If a customer wants to control, so Oracle only gets the logs after Oracle asks and the customer approves, virtual machine log access is a mechanism by which we can remotely collect the logs without logging into the VM, and we can do it under the customer control. Stepping up the next rung, virtual machine command access allows the Oracle person to submit a batch job of commands that are run in an interpreter. So as the Oracle operator, I will create a JSON document that has all the commands that I want to run. I will submit that command to the interpreter. The interpreter will run those commands in a temporary account in a chroot jail using the security posture that we've described, but it won't allow me to directly log in. So you'll see in the audit record a unique temporary account. That audit record will be able to be correlated to my identity. So should I have submitted commands that were malicious or did the wrong things, you know who to go after, or Oracle can find out who to go after. And then those commands are run without allowing me to directly SSH into the system. Sometimes I need to access the system. Maybe the automation isn't complete enough. Maybe there's something strange about the system where a human needs to look at it. System diagnostics allows controlled SSH into the system to look at logs and diagnostic file, but preventing access to sensitive information, changing system configurations, rebooting, or tampering with the audit system. Virtual machine system maintenance. This is how I do a bunch of real work, but not root work. So I can log into the system. I can gain access to components of the system with limited privileges. I can't gain that. The software prevents me from gaining access to the root account, and it does prevent me from tampering with the audit system. Finally, full machine access. This is what happens when I need root. So as root, I can fix anything, but as root, of course, I can fix anything, which is, a benefit and a curse. We still have the audit service enabled. We still have authentication first as a named user. So there still is a mechanism to track that root access to the specific person that did the work. We try to make this easy because we've got to do it at scale. This is in Oracle's best interest. For Oracle to deliver service in the cloud, we have to deliver the service the same way to everybody. The Oracle Cloud is adopted by leading banks, telcos, insurance companies, manufacturers, shipping logistics. We're a who's who of everybody that the mission critical infrastructure that runs our society. We have learned from those people how to do this, and we want to do it the same for everybody, which means we have to do it as the way we need it for the most strict customers. And what we hope is everybody else is happy with the way that we do it for the most strict customers. To make the flow work, we start with a ticket. We integrate the software to check the ticket, make sure that the ticket's only in use for the access request we're doing. If you're using the ticket for something else, meaning somebody else is already working on a different system with that ticket, the software will deny access. The operator with the JIRA ticket will submit an access request with an OCI API authenticated with their multi-factor device. That request goes cross-tenancy to the customer. The customer uses their OCI IM credential, their multi-factor authentication to review the request. The customer approves the request. They can authorize the access, which will start the software process to deploy the temporary account in the chroot jail on the virtual machine. Following the deployment of that jail, there'll be an orchestration of a bastion server and temporary network credentials that will allow that tunneled SSH line number 6 into the virtual machine. Our operator works in the virtual machine where the Oracle Linux audit system can stream the audit logs. Customer can configure the logging service, syslog service, whatever they run for their SIEM system in whatever cloud that they have. This can all be streamed by the customer. The important part is we can send that data in syslog format, a format that most everybody already understands. And of course, if the customer installs their third-party agent on the system that is compatible with the system, that third-party agent could also pick up these logs. The clever way that we do this in OCI to implement separation of duties is there's an access delegation tenancy. It's separate Oracle staff, a completely different organization that operates Delegate Access Control. They run it in their tenancy. They make a cross-tenancy call to the XSCS tenancy through that bastion server control mechanism. That SSH will go across the backend and allow the bastion server connection up into the VM. And this is compatible with at cloud service provider implementation because it uses the same backend that the OCI implementation does. So we have a temporary network, temporary bastion server orchestrated in OCI. We orchestrate it the same way for all of the partner clouds. The thing that's really nice about this is we make it fast, efficient, and straightforward to control. And again, we do it at the highest standard for everybody. So we hope that we can convince most folks that this is a great way to solve the problem, and we use great as the way that we do business everywhere. Audit logs, just as a quick example, this is a picture that describes audit records. The access request ID is a nice unique thing. The requester ID, you see that OCI user OSID, that correlates back with me. You see that temporary user account, that correlates back with me. My PI is not in there, which is great. The workflow ID that you see in there is the ticket. And you can see that I've logged into this test system 4 times, a few times for 23 seconds or 13 seconds, and then for 5 minutes where I've done a little bit of work. So the first part here is we have summary information about what we need to do. This is an HTML report of the Oracle Linux audit records. The nice part with this HTML report is, for folks that are in the business and have run the Oracle Linux AU report utility, if you really know what you're doing and you're good at Linux administration, you can do anything with the AU report. It's harder for people that don't really know what they're doing to process Oracle Linux audit records. So what's shown here is an example of our HTML human interface, where the gray text is an Oracle Linux audit record for me running a command to copy the etc password file to test file, as an example. This Oracle Linux audit record has all the important information about who did what, what's my audit user ID. If I did an SU, this is how you trace my effective user ID and my audit user ID if I changed it. You can see all the arguments to the command. If I were to alias the command to do something else, you'd see it in the audit record. So although it looked like I ran, CP, if CP turned out to be a different command, the audit record would indicate what it really did. If that was a bash script, it would indicate all of the commands that the bash script ran. So it's very nice. And if I spawn a subshell, those audit records are returned as well. Keystroke logging, you'd like to see what I wrote in the file. Here's an example of me calling vi test file. And you can see as we walk down through this particular file, the O here at the very beginning. If Michael watches this, my friend, he'll say, Jeff, you make the same typing mistake every time you do this. But you can see here's the O to open a file in VI. I attempt to type the quick brown fox jumped over the lazy dog. I make a few mistakes. I do a little bit of backspacing. And of course, anyone who's run VI, you all know what escape right quit is, return. So you can see the commands that I've run if I've made any edits to a file really easily. And then on the back end, should there be a security investigation, Oracle's incident response process details how Oracle respond to an incident, which includes Oracle assigning investigative staff to look at what's going on. That security staff that look at what's going on has the capacity to run the APIs to tie the operator to the temporary user. And so in this example, you can see operator list JT Wright. That is my GUID. You could argue that is PI information that we only share under, a particular escalation need, or you could argue that it's my name, right? It's not particularly sensitive, but we can tie it to the particular access request. So the nice part here is when there's an investigation and there's a need to investigate, we can investigate a person. But the other nice part is we can obfuscate that HR information so we can invest without an assumption or the biases that come with a specific person. And we could also investigate without conclusion, right? Somebody says you got to investigate this user. The last thing you want to say is the investigation stops because that user is a friend of mine, right? The security team just investigates the user. They can tie the whole thing up and say, hey, this user ID that is obfuscated is the person that we need to bring in. And then when someone lines up to say, hey, it's Jeff, someone's not like, oh, shoot, he stopped the investigation because it was Jeff. All right, last couple. We'll set this up in the next couple of minutes and we'll turn it over for question. How do you set this up? The first one is you use an OCI interface to create a subscription. It's literally a pull down and a few things to select. Use after selecting the subscription, you create a delegation control. The screen's a little bit hard to see here, but you can see I'm assigning this to an Exadata VM cluster. Oracle Cloud, this will work in any Oracle Cloud thing, which includes all the cloud at CSPs. You could see that I'm selecting a VM cluster. I've actually selected a bunch of VM clusters. So you got a compartment, everybody that you want to control. And then after you've done this, you hit approve or go, and it will use the software orchestration to bring those systems under control. Once the system's under control, there's an access request ID created. We can stream this to email, SMS, HTTPS, custom URLs. You can be notified of this in a manner that you're comfortable with. In this request, you'll see reasons for accessing. If everything is clear, you can hit approve. If you need to interact with the provider, we have an interaction mechanism whereby you as a customer can send a note to the provider for clarification. Is there going to be a reboot? Are you going to access the database? This is a sensitive production system. Don't start an ASM disk group rebalance because our system is sensitive to ASM disk group rebalance. If you got to rebalance, do it with ASM power level 1, because if you use power level 4, we tested and that screws everything up. This gives a mechanism to help clarify any nuances to help prevent mistakes, and it helps remove any ambiguity. This audit record of the communication is memorialized with the request. So if somebody were to start an ASM disk group rebalance, you can see, did they do the right thing, meaning that was the standard procedure and nobody told them not to do it, or did someone tell them not to do that and they didn't understand the question or they violated the direction that somebody had sent? When you approve it, you can approve it now. Get started working. We'd love to get this working. You could also say, this is a great idea, but we can't do it until the weekend. Click approve later, and you can schedule it for 2 p.m. on Saturday or whatever time makes sense. If something goes wrong, you start to see something that is suspect, you can always revoke. Revoking will revoke access. It will create a ragged edge because we will kick the operator out. We will remove the temporary credential. We'll kill any processes associated with what that temporary credential is doing. We will deny that credential from logging in again by virtue of it not being deployed on the VM. It's a very easy security posture to understand. Delete the user is how we prevent using it again. But that will also stop work. So if you stop work and it is in an inconsistent state, you could run the risk of the system being in an inconsistent state, but this is how you can revoke access. And you can, of course, click the download audit report to get that HTML interface to get a nice human readable thing so that you can see what's going on in a way that's easy. So to close it out, Delegate Access Control gives you a first-class PAM service to control Oracle staff accessing your infrastructure. It's the way that you can gain Oracle people as a partner, just like you do with Oracle technology, and you can control them in a way that works for a lot of financial services, banks, insurance companies, telcos, logistics, shipping, manufacturing. We really did our homework. We partnered with Oracle's really biggest customers, and this is a feature that's been designed by and for these industry-leading customers. So back over to you, Tammy. We can close out with questions.
Thank you so much, Jeff. That's a lot of great information. Remember, this is multi-cloud happening. So here's some information on multi-cloud solutions. I'll post the PDF of these presentations into the Ask Tom. So Jeff, you want to send me your latest one that you just used, and then we'll get them uploaded for you to take a look at as well. So we have maybe 2 more minutes. Does anybody have any questions? Do you want to, if you can post them in Q&A, I'm happy to answer those questions as well. Oh, also, if you want to join our external Slack channel, sometimes we have some good information and conversations on our Slack channel, and also get notified of when we have different webcasts on different topics. Okay. So, Jeff, there doesn't seem to be any questions at this point. You're too thorough. Any last minute thoughts, Jeff? For multi-cloud, this just works after you provision your infrastructure and VM cluster and your database, then you can go over to the OCI console to run it as well. Do we have APIs and can or Terraform? No, only APIs would work with this or the console.
Oh yeah, all the OCI interfaces work with it.
Okay.
One question that wasn't asked that I should have indicated on the slides is someone might wonder, is this compatible with my existing access method? So can I use my PAM service that I use for my normal systems with Delegate Access Control? And the answer is yes. Delegate Access Control runs in tandem and alongside of any other software that the customer might use to control their staff. So if the customer uses LDAP to control their staff, they can still use LDAP to control their staff. If they use a PAM software, their favorite provider that they use with Oracle Linux, that needs to be tested and validated, obviously, alongside of Delegate Access Control. But the intent of Delegate Access Control is to be able to operate in tandem to control Oracle separately from the customer's existing PAM services.
Thank you. Miguel asks, is it planned to have this delegate access control also to external partners so Oracle partners can provide specific type of support to their customers?
Great question. So
Very
this
good
is
question.
now a forwards-looking question for a non-shipping software that requires safe harbor, but that is our intent. So the roadmap for the software is to build the interfaces so that customer tenants, any arbitrary tenancy can create a delegate access control service provider. And once that delegate access control service provider has been created in an arbitrary tenancy, an arbitrary tenancy can subscribe to it. It can be the same tenancy or different. So we hope to imagine that customers will build their own DBA team. Their DBA team will publish their own DBA service, and then their DBA, controller people will subscribe their VMs to their DBA team. A developer team might also have access, and you could say, hey, the developer team is subscribed to test infrastructure and dev infrastructure. The DBA team service is subscribed to prod infrastructure, as an example. And of course, if you're a third-party provider, one of Oracle's many great partners, KPMG, Accenture, pick your favorite. We hope that they will, in OCI, host their tenancy to deliver their services, and they can gain the same leverage of one access method to use on all the Oracle database services.
Awesome. Well, thank you for that. Okay, so we are out of time for this session, and I hope you enjoyed this and find it very useful. I look forward to seeing you next month on Multi-Cloud Happenings. Have a great day. We'll talk to you later. Bye.
Thanks.